Dear students, now we solve question number 22 from the question series of IIT JAM 2024 mathematics question paper, and the question is given from linear algebra and the topic is linear transformation. The question is, let P7x be the real vector space of polynomials in the variable x with real coefficients and having degree at most 7 together with the 0 polynomial. Let T such that P7x to P7x be the linear transformation defined by T of f of x is equal to f of x plus d of f of x by dx. Then which one of the following is true? There are 4 options are given. So let us try to find out the correct option. We do not solve this problem by finding the matrix of the given linear transformation, because the vector space is P7x and the dimension of P7x is 8. So we get an 8 cross 8 matrix. So the order of the matrix is very big. So from that matrix it is difficult to find out the correct option. So we apply another method. So here the given linear transformation T from P7x to P7x is defined by T of f of x is equal to f of x plus df of x by dx. So now we find out the kernel of the linear transformation. So ker t is equal to f of x belongs to P7x such that T of f of x is equal to 0, because 0 is the identity in P7x. So is equal to f of x belongs to P7x such that T of f of x is f of x plus df of x by dx is equal to 0. Now we solve the differential equation. So f of x plus df of x by dx is equal to 0, or df of x by dx is equal to minus f of x, or df of x by f of x is equal to minus dx. Integrate both sides, we get log of f of x is equal to minus x plus log of c is equal to log of c e to the power minus x, or f of x is equal to c e to the power minus x, but it is not a polynomial, so this does not belongs to P7x. Therefore kernel of T is equal to 0 polynomial, because c e to the power minus x, it does not belong to P7x. Therefore kernel of T is equal to 0. It is the additive identity of P7x. Therefore T is injective, because we know that a linear transformation T from a vector space to another vector space is injective if and only if ker T is equal to identity. Therefore T is injective. Since P7x is a finite dimensional vector space. P7x is a finite dimensional vector space over R, and dimension of P7x is equal to 8, and T is injective, therefore T is surjective. Therefore T is surjective. But in option A, T is not a surjective linear transformation. This is false, because we see that T is injective and T is a linear transformation from a finite dimensional vector space to the same. So T is surjective. Therefore option A is false. Now from option B, it is said that there exists k belongs to natural number such that t to the power k is the zero linear transformation. So option B. For option B, T of f of x is equal to f of x plus df of x by dx, or t square of f of x, that means t of tf of x is equal to t of f of x plus df of x by dx is equal to f of x plus df of x by dx plus d of this. So d of this means d of f of x by dx plus d2 f of x by dx. Derivative of this, so f of x plus 2 df of x by dx plus d2 f of x by dx. Similarly, if we find out t3 of f of x, we get another polynomial. Therefore we cannot find a natural number such that tk of f of x is 0. So here we cannot find, therefore t to the power k f of x not is equal to 0. Therefore option B is also false. In option C, 1 and 2 are the eigenvalues of t. Suppose, for option C, suppose 1 is an eigenvalue of t, then there exists a polynomial f of x belongs to kernel of t minus I, because we know that if 1 is an eigenvalue of t, then t of f of x is equal to 1 into f of x, where f of x is called the eigenvector of the linear transformation t corresponding to the eigenvalue 1. That is, or t minus I of f of x is equal to 0. That is, there exists a polynomial f of x belongs to kernel of t minus I. Now t minus I of f of x is equal to d f of x by dx. Kernel of t minus I is equal to f of x belongs to p7x such that t minus I of f of x is equal to 0 is equal to f of x belongs to p7x such that t minus I of f of x means df of x by dx is equal to 0. Therefore, f of x is a constant polynomial is equal to constant polynomial. Is equal to 1. Therefore, we find an eigenvector corresponding to the eigenvalue 1. Therefore, 1 is an eigenvalue of t. Now we check whether 2 is an eigenvalue of t or not. Similarly, if 2 is an eigenvalue of the linear transformation t, then there exists a polynomial f of x or p of x belongs to p7x. There exists a polynomial p of x belongs to p7x such that px belongs to kernel of t minus 2I. Now t minus 2I of f of x is equal to t of f of x minus 2I of f of x is equal to t of f of x means f of x plus df of x by dx. So f of x plus df of x by dx minus 2 I of f of x means f of x, because I is the identity linear transformation. So this is equal to df of x by dx minus 2 f of x minus f of x. Now kernel of t minus 2I is equal to p of x belongs to p7x such that t minus 2I f of x is equal to 0. Therefore, is equal to p of x belongs to p7x such that t minus 2I of f of x means df of x by dx minus f of x is equal to 0. Now we solve the differential equation. df of x by dx minus f of x equal to 0 or df of x by dx, a df of x by dx is equal to f of x, or df of x by f of x is equal to dx, or we integrating both sides, we get log of f of x is equal to x plus log c is equal to log of c e to the power x, or f of x equal to c e to the power x. But it is not a polynomial, therefore there does not exist a polynomial px such that px belongs to kernel of t minus 2i. Therefore 2 is not an eigenvalue of t. 1 is an eigenvalue of t, but 2 is not an eigenvalue of t. Therefore option C is false. Therefore option C is false. In option D, we see that there exists r belongs to n, that means r is a natural number, such that t minus I whole to the power r is the zero linear transformation. Now t minus I of f of x is equal to t of f of x minus I of f of x is equal to t of f of x, means f of x plus df of x by dx minus f of x is equal to f of x cancel, d of f of x by dx. So option D. Therefore t minus I of 2 f of x is equal to t minus I of f of x is equal to t minus I of d f of x by dx is equal to t of df of x by dx minus I of df of x by dx is equal to df of x by dx plus d of df of x by dx minus df of x by dx, it is cancelled, is equal to d2f of x by dx2. Therefore we see that when is power 1, here 1, when it is 2, here 2, therefore t minus I whole to the power r f of x is equal to dr of f of x by dxr. Since here f is a polynomial, f of x belongs to p7x, a polynomial of degree at most 7. So if we differentiate the polynomial f of x, one time we get 0, because the degree of f of x is finite. So when we differentiate f of x, we get a constant term at last, and the derivative of the constant is 0. So there exists r belongs to natural number such that t minus I whole to the power r is 0 transformation. Therefore option D is true. Thank you.